Finish those last two. Finish those two and bring it back to me. Alright. Excuse me, guys. Again, we have an AP exam that we got to get ready for at the beginning of May. I need eyes and ears. I need to get going. Demonstrate your understanding. I think I only have about half, maybe a little over half of us that have taken that demonstrate your understanding. But we also need to go over it. So, if you have not taken that demonstrate your understanding, you have until we'll have Mu Alpha Theta in the morning. You have until tomorrow morning to take it. So, no, I have an officers meeting tomorrow morning. And didn't I send the email that the Mu Alpha Theta is Tuesday afternoon and Wednesday morning? So if you're in Mu Alpha Theta, one of those two.
Is it Wednesday morning?
Tuesday afternoon or Wednesday morning? Yes, ma'am.
Could I do 4 o'clock?
So yeah, sorry. You have until tomorrow morning to get it done. So you can come in during advisory. You can come in during 4th block. You can come in during even 3rd block if you want today or tomorrow morning to do that demonstrate your understanding so I can grade them and get them back to us to go over on Tuesday. So Frere models, we got those submitted. I wanted to talk about projects, I think, next. Only 3 of us had submitted a proposal by this morning. We're supposed to get them in, I don't know, Friday or something like that?
3 groups or
3 groups, sorry, yes, 3 groups.
Sounds a little better.
Sorry for not clarifying that. So here's what I want to point out really quickly. Honestly, guys, I need a little bit better. For even those who submitted, there's some things that were fine, but let's look at these examples that I uploaded into Schoology. So, these, and for some of us, it was okay, but in the nicest way, I need more interesting questions, right? This is somewhat more interesting. So I'm trying to figure out if the wording of a question can create response bias. So, does music affect studying? These are good questions. Do you study more efficiently while listening to music or studying in silence, right? Versus a biased one where they're adding extra information in. A recent study has shown that listening to music while studying will hurt your academic performance in school. Do you study more efficiently, or do you think you study more efficiently while listening to music or studying in silence, right? That is using language that is adding extra information in that could, now is it guaranteed to create bias or introduce bias?
No.
No, that's a hypothesis that this group came up with that they think is going to introduce bias. By the way, when y'all analyze this data, could you do confidence intervals or hypothesis testing based on what we have been studying? Yes, and I would highly recommend that you practice using that. So let's look at the second option, right? So that's introducing response bias through the questioning. What's example 2 that I liked? Okay. So does anonymity change the answer to sensitive questions, right?
That's a big word for Elmo. Can you explain it?
Anonymity?
Yes.
Anonymous. So you don't,
okay, there we go.
yeah, you don't have to put your name down. We chose this topic because it reminds us of the difference between anonymous Twitter polls and tweeting a public question, right? We see examples of this bias every day. His phone. I think that's.
I think it's the purple one.
Thank you. Someone didn't hold their phone up. Take it. All right. So, do you brush your teeth for the entire recommended time of 2 minutes? Right. So they think that it being anonymous versus non-anonymous will change the responses. Notice they also gave the data collection method. I will say the data collection method for those that were submitted was pretty strong. It's the question that I want to be better, or the type of bias that you're thinking you can implement or introduce. I think maybe it was project 7 in here. So again, these are examples that you can use. Is this the one? Yeah, so this was a great example. The purpose of our experiment was to discern what effect the race of the interviewer has on the responses of the subjects. We randomly chose people and asked them the following question: given the recent media attention on the altercations between police and African Americans, do you believe the officers involved should be held accountable for the deaths of these individuals, or were they justified? And so they had Jaden, an African American, asking these questions, and Alyssa, a Caucasian, asking these questions. Right? Like these, I think, and this is something I thought y'all would look at and see examples of. These are interesting questions, right? They're relevant questions to the world around you, questions that hopefully you find pertinent to yourself, right? In some way, shape, or form. The whole point of stats is not to ask trivial questions, but impactful questions, questions that are relevant to your lives. So I do want a resubmission. You can keep the study design for the most part. I'll look back and see if I need to email any groups, but better questions. The one thing I will note is this: you don't have to do the surveys at school. One of the surveys, I think they talked about going to the mall and asking random people at the mall, right? You can, but you don't need random. Why do you not need random in this case?
Because you're doing an experiment.
Because we're doing an experiment, right? Cause and effect. Now, you could and should have random what? Assignment, right? So, for example, when you go to talk to someone, you could flip a coin, right? And if it's heads, you ask the person this question. If it's tails, you ask them the other question, or you do the two different treatments. By the way, do you have to only have two different treatments? No, right? African American male and I'm guessing white female, or I would assume African American male, right? But notice there could be confounding there. Is it race or is it gender, right? So could you split it up into 4? You could recruit people to help you ask these questions. Anonymous versus non-anonymous. So again, I just want you to make sure that these things are not trivial. My recommendation would be, resubmissions need to be sent to me by Wednesday afternoon, because I want you to have a chance in school to collect that data on Thursday, because that way if you can collect your data on Thursday, then you have a long weekend to do the project, to analyze the data, to talk with your group. What's up? Why do you look like that, Lexi?
Because we're gonna have a long weekend.
Right. Would you rather, work on this project while you have other schoolwork going on? So, you have a 4-day weekend. Listen, if you look at these poster projects, how long do you think they actually took? Like, and if you take 3 hours, and even like 3 hours, I think it might be a good amount of time. But if you split that over 3 people and you just check each other's writing and things like that, I think that's very doable. So one person does the introduction, one person does the experimental design. Like, y'all need to talk to come up with the question that you're proposing, the method of data collection, but split it up and then check each other, make sure it's good. I don't think that it should be a terrible amount of time, but I do want this to be purposeful, and I want it to be something that prepares you for the AP exam. Nothing I do is going to be random or to waste your time. It is always, for better or for worse, to help you develop your understanding of statistics and be ready for the AP exam. So again, examples, right? We don't have to have the most in-depth stuff, but you have great examples here to refer to. What are your questions about the project stuff at this point? Or anything else? Okay.
Do something different.
Do what?
I don't know, I think I'd rather do a whole different kind of project than do something like this.
Well, it's like I can't make everybody happy all at once. I will give you all more freedom at a later point, but the point of this is to investigate the idea of bias and to do an experiment and to learn how to analyze that experiment. So like, this is going to give you a lot of review of content that we have studied this entire semester, right? So that's the goal of this project. All right. So hypothesis testing, that's what we've now gotten into, going past confidence intervals. So this is a quick recap, reminder of where we ended roughly on Friday. So what's the difference between a null and an alternate hypothesis or alternative hypothesis? what's that null hypothesis going to be?
We believe the null hypothesis.
So it is what someone
Assume.
assumes or claims, right? Like that company claimed 1 in 6 wins, right? And so we assume that they are telling the truth because what did I correlate that to? Or what did I make an analogy to? The
Claim. Like,
you can do that outside class. Thank you. All right. I think it was the justice system. You are assumed what? Innocent until proven guilty, right? We are always assuming innocence until proven guilty. And so our alternative hypothesis is what we believe might actually be true, and we're collecting evidence, right, against the null hypothesis and for the alternative. And so keep that in mind. I don't know that we actually got a chance to talk about some of the mistakes, the notation that we use for each. So first off, what symbol do we use for a null hypothesis? Melissa, do you have these notes pages? Come on, you're going to let me get started on the whole day and not remind me of this? I might have to print because my organization is whack right now. I don't need your negativity in my life. Alright, so here's the confidence intervals and hypothesis stuff. I'm just going to reprint notes. Oh crap, did I never printed the next few pages of the notes for y'all, did I? Just the first page. Yep. Mr. Ellis, can you go make copies for me?
Yeah.
I literally even thought, oh man, I don't have to make any copies this morning. Guess what? I was a liar.
I put all like the data analysis together. You think you can just do posters?
Alright, now listen, this is the chapter 8 notes.
It's a reason you just automatically.
Okay, so here we go. Alright, what's the notation we use for a null hypothesis?
It should be like an H with a subscript O.
Yeah. Have y'all ever in like a physics class seen this?
I didn't take this.
No? V naught, initial velocity? Okay. Yeah, so whenever we do that subscript of 0, it just means initial or the not, we say V naught, but the initial hypothesis, the null hypothesis is another way to say that. And so what's it for an alternative hypothesis?
Alternative should be HA.
HA, right? Alternative hypothesis. Now, I'm going to go ahead and talk about a couple of common mistakes, and I think this is going to cover everything, but I'll check soon to make sure it's right. The null hypothesis. How are we going to write the null hypothesis every time?
The null hypothesis.
What does it start with? At least for proportions, it's going to be
Allegedly, maybe.
P equals. Haven't we done some value?
Oh, the p-value.
Well, not, okay, so we need to be careful about this. So, it's not the p-value. The p-value is what we the data that we collect. So, let's say it this way. Notice p is equal to some parameter. It's the null hypothesis. What was the p equal to in the 1 in 6 wins? 1/6, right? Like we assumed that how many people won? 1 out of 6. So what would the alternative be? There's 3 options for an alternative. So P could be greater than, P could be less than, or just not equal to. Okay? So those are the notations. Now, should I use P or P hat?
In these instances,
In those instances, yeah. Why P?
Because you're talking about the truth position.
Right. What's unknown, P or P hat? P. We would have a sample proportion, wouldn't we? What is unknown, or what are we trying to make a prediction and inference about? It is the P, the true proportion, the population proportion. So keep in mind, that's one of the most common mistakes, is P a parameter or a statistic?
Here's a parameter.
P is a parameter, it's for the population value. The most common mistake students make is they put a statistic here instead of a parameter, okay? So keep in mind, hypotheses are all about the parameter. We know the statistic.
So we don't have this page, right?
I thought this was
We
the,
do have this
you
page.
do have this
We already
page.
did it.
Yeah, we started talking about this one. This was, no, chapter 9.
Yeah.
Hold on. Yeah, keep going. See, I did have the whole thing. Oh, I made corrections, didn't I?
Section 2.
Keep going.
Oh, Mario.
Oh, it's on the back.
Yeah, you can find it.
Nope.
Mario never responds, but
Right here.
I did mine.
Press that notify.
Okay, sorry, it's on the bottom of page 1.
Guess what I found?
You said what?
Alright,
Notes.
so we have our null, we have our alternative, some of the most common mistakes. Students write this about the statistic instead of the parameter. The other thing to remember is the null hypothesis is always a statement of equality. The null hypothesis is always a statement of what? Equality, right? The alternative is inequality in some form. Alright? And I do remember, because we did talk about this, I think I accidentally skipped this section and talked about this right here.
Yeah.
So what was the difference between a one-sided and a two-sided alternative hypothesis? Which one of these would be one-sided, which one is two-sided?
The one on the bottom is two-sided.
Why is this one two-sided?
Because you look at both ends.
Because you gotta look at both tails, right? And so these are,
One-sided.
and so the reasoning for that one-sided again is,
The side.
I'm only gonna get how many statistics?
You're only gonna get one statistic.
I'm only gonna get one statistic. So if here's P hat, and it's one-sided, I'm just gonna look to the right. Greater than. But if it's two-sided, just not equal to, here's my P hat, how am I gonna figure out where it is on the left tail?
You get the negative of the P hat.
It's just the, well, the,
Inverse.
it'd be the negative, not of the P hat, but of the standardized statistic. Because remember, like, it's like, let's say P hat is 0.8, can you have negative 0.8 on this? No. So it'd be we always convert, that's one of the big reasons why we convert it to whatever that z-score is. But it's the same as this one, just the negative, the opposite. And so we'd have two tails. Okay? We'll get practice with it, but that's just a slight introduction into the idea that if it's a two-tailed test, that's the not equal to, and so we would take care of it that way. We'll talk about how we do that soon. But the calculator also does the majority of the work. All right, what are your questions through this page? I thought so. I think I made some changes, which is why I reprinted. I may not have made as many changes as I thought, but I think I made some changes. I know for sure that beginning, that first page was different, because that was the 1 in 6 wins, right? And that's not what was in the original first page that I gave you.
So we have to swap it all over now.
No, 'cause I think I reprinted that first page for you. Yeah. Yes. But I think I made more changes throughout the rest of it afterwards, which is why I reprinted that. All right. Questions? Going once? Going twice. Go for it. Go quickly. All right. So, notice, and Joseph, you brought this up earlier, the p-value, right? Do not forget that p is a parameter. What is a p-value?
It's like
Oh, it's the
Like the
probability of
problem
getting a
with
more
someone
extreme
like this.
statistic or something.
So remember, what is this area under the curve going to correspond to?
P-value.
You said, what was the other word you used though?
That value is more extreme.
So there was a P word you used.
Oh, really?
It's probability. Guys, P values. These are the probabilities. So the probability of getting that extreme of a statistic or more extreme given what?
Given the claims true.
Given the null hypothesis is true, right? Another way to say that is by random chance alone. Okay? So we've seen this several times throughout the chapters that we've done where we looked at, hey, what's the probability of getting this value by random chance alone? What's the probability of getting this extreme of a statistic or more extreme, assuming that 1 in 6 actually wins, right? So, probability of getting that extreme of a statistic or more extreme given our null hypothesis true, so by random chance alone. What? Just quick note and reminder of this. What was this that we did with 1 in 6?
Simulation.
It was a simulation, right? And what did we use for that simulation? We used a random number generator. Remember I said by random chance alone over there? So we have a random random number generator, and when we did that, what was the probability of getting 3 winners or less by chance alone? That probability was 0.177, right? Which means, is that somewhat unlikely?
Yeah.
Yes, but is it so unlikely that I think the null hypothesis was wrong?
No.
No, right? So, do not forget, right, it's the probability of getting that extreme or more extreme given the null hypothesis is true. And I think we did this on Friday, right, where we did the probability of that z-score. Remember how we did that process? And didn't we get a pretty similar probability calculating it using the normal distribution, right? So we'll get some more practice with this, but so how do we use p-values to make conclusions? So if that probability is really low, then what?
Then the chances of it happening just by randomness alone are too low for us to. It's low enough for us to accept the what is it, alternative hypothesis?
Yeah, right here. You want to know the most common error that students make in their conclusions?
You don't accept the alternative.
The language, that idea of accepting the alternative. Be careful, right? You have the right idea, but that's the language that screws us up on the AP exam. You never accept the null hypothesis, okay? What are the 2 possible conclusions? That we reject the null hypothesis. So we have find evidence to reject the null hypothesis, but what's the opposite of rejecting?
Accepting.
Fail to reject.
We can't accept something like that.
Yeah. We don't ever accept something to be true. We either reject the null hypothesis or we fail to reject the null hypothesis.
Oh.
Okay? That is the language on the AP exam, right? We assume innocent until proven guilty, right? Or so we either fail to reject their innocence or we reject their innocence, concluding they're guilty or not guilty. The same is true for this language on the AP exam. So we reject the null hypothesis. I'm going to leave a little gap in here for a second because we're going to come back to it. And so if we reject the null hypothesis, what do we have evidence for?
The alternative hypothesis?
The alternative hypothesis, right? We're going to have evidence for it. Now, I need you to hear me clearly on this. 1 in 6 wins, we had evidence that the null hypothesis was wrong, right? But was it convincing enough?
No.
No. And so that's the language we need to be careful about. If we reject the null hypothesis, we have convincing you will also hear that worded as statistically significant. If you ever read a study in the future, which Deke and I were talking about, like, how often are we really going to use this math or use this statistics before school today? You will actually see studies, and you won't have realized it before, but now when you start to see those studies, when you see them say, hey, this was statistically significant to this level, what they're saying is, it was so unlikely by random chance alone that we conclude the alternative hypothesis, or we believe the alternative hypothesis. So we have convincing evidence for the alternative hypothesis. So if we fail to reject the null hypothesis, then what? There you go. You do not have statistically significant evidence for the alternative hypothesis. Okay. So if we reject the null hypothesis, we have convincing evidence for the alternative. If we fail to reject the null hypothesis, we don't have statistically significant evidence or convincing evidence for the alternative. You can use either of those language pieces there.
And it's like 0.05, right?
That's what we're about to talk about, yeah. So the most common level of significance is what? 0.05. We talked about that a few times this year already, right? Notice that would in some ways correspond to what confidence interval or what confidence level?
95%.
In some ways it would correspond to a 95% confidence level. Just based off of that, any other ideas what the other two common significance levels might be? 1%, 99% confidence level, and 10% for the 90% confidence level. They're not exactly the same, but they are related to each other. So, there is a symbol that we use. So, the significance level, right, statistically significant, it helps when you put an F in there. Significance level is called, anyone know what that Greek letter is?
A fish.
It was, I used to know it was.
Alpha. Okay. The significance level is called alpha. Fish, yeah, no, not quite fish. It's called alpha.
Well, that's all right.
Okay. So it does kind of look like a fish. So the significance level. So if we reject the null hypothesis, we have statistically significant evidence for the alternative. How are P and alpha going to be related? Is P going to be greater than alpha, or is it going to be less than alpha? So the P is my probability, right? My p-value.
Yep.
And when do we reject the null hypothesis? When P is less, when it's small, right? Because that means it's super unlikely to happen by random chance alone. So if P is less than alpha, we have statistically significant evidence for the alternative. Oh, I missed the word evidence in here. I am so sorry.
I don't forget you.
Thanks, I appreciate it.
My daughter.
Wow.
So,
I didn't.
when would we fail to reject the null hypothesis?
When P is greater.
When P is greater than alpha.
Oh, good job.
Okay.
I think he just feels left out now.
Interesting.
Because remember what that's saying is that we have a probability of getting that extreme of or a more extreme statistic given the null hypothesis is true. It's large enough, that probability is large enough that we don't have statistically significant evidence for the alternative.
This language sucks.
Yeah, you get used to it pretty quick though.
Okay.
So, by the way, sorry, I went ahead and actually answered it. How do we use p-values to make conclusions, right? Well, how do we use p-values to make the conclusions? Well, if p is less than alpha, or just, we can in general say if p is small, right? If p is small, that means we have a low probability of it being by what? Chance alone, right? And if it's, so if p is small, low probability of happening by chance alone. And so if it's a low probability of happening by chance alone, it's probably not random. It's probably something is wrong. Our original assumption was false, right? Which is why we reject or fail to reject. There's something I was going to say. Oh, I know what I was going to say. You know what I'm missing from these two conclusions right here? It's the most important part of statistics.
The statistics.
What do you think, Alyssa? Okay, maybe units. Units would tie into this. That's a good idea.
Context.
Say it again.
Context.
Context, guys. We're not talking about random numbers in a vacuum. Everything has a what? A context. So when you do this, I don't care where you put it, at some point in these conclusions, whichever one it is, you need to have what? Context. Do not write on the AP exam without context. Do not write on the AP exam without context. Alright, let's look at the book. And then we're going to do one practice problem. And then you know what we get to do after that?
Skittles.
Skittles! That's what I'm talking about. Hey, what pages did it say in the book?
I still can't do it.
588.
I still have a week.
Thank you. I was just about to ask that. So guys, notice once again, 588. Right here. How do we know where the important words are that we got to know?
They're in the green box.
They're in the green boxes. Don't forget, when we do Frere models, you can use your notes, but also I did the Frere models in the order of the book. Right? So the p-value of a test is the probability of getting evidence for the alternative as strong or stronger, so that extreme or more extreme, than the observed evidence when the null hypothesis is what?
True.
True, right? That's what it's all about. There's more context here, right? They give that basketball example, right? Notice again, like if you ever go like, man, Mr. Kenny, that's just too much to read when there's actually the whole book. That's fine, right? Like you can skip these problems. They're not bad, but they're just practice things to show you. Here's a couple of details context-wise. So a p-value measures the strength of evidence for the alternative hypothesis, right, against the null hypothesis. So we had a sample mean, and notice how they use the sample mean here. So can we do hypothesis testing with means?
Yeah.
Yeah, what is this unit about though? Proportions, right? We're not getting to the means yet. That's what next unit's about. Right now we're dealing with proportions, but you can do the same exact thing. So notice that statistics automatically gives evidence for the alternative, because 1198 is less than 1300, but that's not convincing evidence yet. We have to calculate a what? P-value. Notice, and I love this notation, I had never seen it until literally working through this book, reviewing to prepare this lesson. What we're saying is, what's the probability of getting this statistic, or more extreme, given the null hypothesis is true? That's what we're saying, by random chance alone. And I mean, that's a pretty low probability, but is it low enough for statistical significance? No. Okay. It is not low enough for statistical significance. What's that marker that we usually use? 0.05, right? Okay. Yeah, I would. You can do it, but anyways, so right here, making conclusions. Final step is to draw a conclusion. So if the observed result is unlikely to occur by chance alone, when the null hypothesis is true, we reject the null hypothesis, or we fail to reject. And literally, those of us who are like, oh, I hate that language. Notice, and this is every time I've ever been to an AP training, they use this language, they talk about it. It's consistent with what actually happens in a criminal trial. Once the jury has weighed the evidence against the null hypothesis of innocence, they return one of two verdicts. Guilty, they reject the null hypothesis, or not guilty, they fail to reject the null hypothesis. That doesn't guarantee that the defendant is innocent, right? But they do not have convincing evidence of guilt. Okay? So, notice here's the language, and this is exactly what we just talked about. If that p-value is small, we what? Reject the null hypothesis and conclude there is convincing evidence for the alternative. Notice, Ashton, what language are we not using in these conclusions?
Accepted.
We are not accepting anything. If you say accept, you will be, even if everything else is perfect, be automatically dropped from an E to a P on the free response. You'll be dropped from a P to an I, stuff like that. So we do not accept. Right? Significance level, alpha is the value that we use as a boundary for deciding whether an observed result is unlikely to happen by chance alone, when the null hypothesis is true. Let's talk through all that.
Mr. Kenny,
Sir?
on the AP stats exam, can you have a correct answer and still get an I?
I think you'll get a P. Well, it depends. So, like, if they ask you to do an inference test, right, and you come to the right conclusion, but you have no evidence to back it up, I mean, you have a 50-50 shot of correctly rejecting or failing to reject the null hypothesis, right? But if you have no evidence to get there, then yeah, probably.
Oh.
Yep. But again, there's going to be 3 or 4 things that the AP exam looks for every time, so we're going to look at that. Notice right there in red, what does it say? Never accept the null hypothesis or conclude the null hypothesis is true. And so just in general practice, not using that null hypothesis. That language that we talked about in the notes, that AP exam tip right here is what you want to notice. Your first sentence should give a decision about the null hypothesis, reject or fail to reject, based on an explicit comparison of the p-value to a stated significance level. The second sentence should provide a statement about whether or not there is convincing evidence for the alternative in the context of the problem. Notice that hits every part of what we just talked about with that. Now, we're going to talk about errors after we do some cool stuff with Skittles. Before we do cool things with Skittles, though, let's do this one thing right here. So let's go to vertical surfaces, get our ideas up, but let's do some new random groups.
No.
Yes.
Please. No.
I want to talk to people with everybody but Bryson, right?
Okay, well, it's still
I
edible.
talked to 95% of the people in this class.
It is edible, because I eat it. Haley, are you eating your...
All right. Group 1 on this whiteboard, Group 2 on this whiteboard, Group 3 on this chalkboard, Group 4 on that chalkboard. Let's try to efficiently work through this. I'll be supporting you
When you work
somewhere between
together,
5 and
these groups.
somewhere between there.
Where did you tell me you were?
I'm just gonna brush it.
So Austin, Logan, Lexi on that chalkboard.
Thank you.
Yeah, there we go.
He's good. I remember his name, so he's good now. As long as I remember your name.
Things. Literally the question A asks about defining the what? The parameter of interest. Use that language to your advantage. It's literally what the person is looking for, what they're interested in. And so what are they interested in? They're interested in more consistent or variability, right? Hear me clearly on this, okay? I'm going to show you 2 things to pay attention to when it comes to the AP exam and talking about hypotheses. First off, my null hypothesis, right, is being defined as what?
15.
Is what?
15.
I need something else with that 15.
15 yards.
I need something else with that 15 yards. What is it? Not P equals
Sigma.
sigma. Remember how this is all about variability?
Yep.
And what's the parameter for variability? Standard deviation, right? So that the standard deviation is equal to
15.
15, and we can put the yards in there, but we can say 15 for now. Alternative,
Less.
it's less.
Yeah.
I saw some people saying not equal to at first. Why does it need to be less in this problem?
We wanted to be less variable.
He wanted more consistent, less variability, so it needed to be less than 15, not just not equal to. Does that make sense? But I want you to look at this again, and this is important. What in the world do we mean by sigma?
The standard deviation of like distance traveled with new club.
So, yeah, there we go, population standard deviation. So notice, when you set up these hypotheses like this, you have to define what that parameter is. Make sure you do that. Where sigma is the, and I could say population, what's another word I could use here?
Total?
True.
True. Remember how true is another word for population values or the parameter values. So you could say population or true, I'm just pointing that out. Where sigma is the true standard deviation of yards hit with his new 7-iron. With, we could say Mike's new 7-iron. What do we always need to include? Context, right? So I always set up my hypotheses first, and then I define my parameter, right? Where sigma is blank, where mu is blank, okay? Now I'll go ahead and tell you, I don't think we're ever going to do hypotheses tests about standard deviation or anything like that, because what do we talk about, Tyler? Why did we say we're probably not going to actually do hypothesis testing with sigma?
Because it's on the F thing.
The F thing,
Yeah.
the F distribution, it's not a the standard deviation does not follow a normal distribution, so we're not going to actually do hypothesis testing with it. This is just to help us illustrate and point some things out. Remember, and you originally had central limit theorem here, but what is the central limit theorem for? Means, right? Every statistic has a different thing for it, and so the F value distribution is actually skewed. It's not normal. But we have parameter of interest, we have hypotheses. What was the evidence for the null hypothesis? Well, that's that this is less than sigma, right?
Yeah.
But did we have convincing evidence? No. What was the p-value?
0.28.
Right? So we did not have convincing evidence. So like in our conclusion, would we reject or fail to reject our null hypothesis?
We failed to reject.
We fail to reject. We do not have convincing evidence. We fail to reject our null hypothesis because p is greater than alpha. What would we need to say after that? There is
No
or not
enough evidence to
Support that his 7-iron.
consider the alternative hypothesis plausible.
You can say it that way. I will say this. There's just not enough convincing evidence for the alternative hypothesis. That's how you would word it. There is not statistically significant evidence, or there is not convincing evidence for the alternative hypothesis. That's it. Okay? That is not what this is asking, but I will point, I know it does say, sketch a picture of what is being calculated and interpret the p-value. So, I know Ashton was talking about this and he wasn't sure which side to put the p-value on. Why does it have to be on the left side?
Because it's only 2 weight.
Because it's a less than, right? It's one-sided and it's a less than. So that statistic, whatever, well, Sx is also below 15, right? And so there's that as well. We'd shade there, this area is 0.28. And So the probability of getting what? What is that p-value? That's the probability of getting,
13.9 or less.
so 13.9 or less, right? That statistic or more
Extreme.
extreme. So that value or less by
Random chance alone.
by random chance alone is 0.28. Right? The probability of getting 13.9 or less by chance alone, ooh, we're missing something.
Context.
13.9 yards, yeah, or getting, you can say that, no, that's not what I'm thinking we need. What does the p-value assume?
Assume that the hypothesis.
Assuming the null hypothesis is true. So the probability of getting this or less by chance alone, given sigma equals 15, or actually I guess I should put that up here, or less given sigma equals 15 yards by chance alone is 0.28. Gotta remember that's the probability assuming the null hypothesis is true. All right. So what conclusion should we make? Part C. I forgot to tell you that was on the back side. We already talked through it. Or it's on the next page, I think. Yep. So on the very next page. So what conclusion should we make? We should, so fail to reject what? The null hypothesis. Why?
There's not convincing evidence for the.
How do we know there's not convincing evidence?
Because 0.28 is greater than 0.0.
So P is what?
0.28
Is equal to 0.28, which is,
greater than 0.05.
remember the textbook, which I like the way the textbook recommends it. It's a formula that you can follow every time of, we either reject or fail to reject the null hypothesis. Why? We explicitly compare P to alpha, right? I explicitly compare P to alpha. What comes after that statement about the null hypothesis? There's something else with that context. There is not what? Significant evidence or statistically significant evidence. Be careful, because there is evidence, right? It's statistically significant or just convincing, right? There's not convincing evidence. All right, from here, evidence for the alternative hypothesis of what?
Sigma less than 15.
So that for the alternative hypothesis that the what?
The club will lower his, make it more consistent.
At the standard deviation.
I was like, guys, your alternative's right here with the context. You need to use this alternative hypothesis with that context so that the true standard deviation of what?
Yards hit with Mike's.
Yards hit with the new club the new 7-iron is what?
Less than 15.
Less than 15. I know that it's like, man, it's so much to write, but it is a very procedural thing once you get there. It's two statements every time. Null hypothesis with your p-value, alternative hypothesis with your context. And this is also the first time we've done this, so is it supposed to be like, oh, I'm acing it already? No, it's a learning process. Stay calm. What's up? Hold on one second. Let me get y'all started on one thing.
I never will.
Skittles time.
Skittles.
What's up?
Is that 15?
Yeah, because it's 15 yards, right?
Yeah, I just.
Okay. So, I would wager it's not just many students, many people claim that they can taste the difference or the different colors of Skittles. Today we will conduct an experiment and perform a significance test to see if students really can taste the rainbow. Okay, so this is the Skittles task that you have out. And so here's where I want to start. First off, I'm going to generate two groups, or not two groups, I'm going to generate groups of two.
Using a random generator.
Okay? Yep, gotta use that random generator. Okay? So, with these groups of two, here's what I want us to do. First off, I want to make sure we have no phones out distracting us while we do this activity. Second off, I want us to do, how are we, what do we need to do to make sure that we're actually seeing that you can taste the Skittles?
Gotta be blindfolded.
We need to be what?
Blindfolded.
Oh, alright,
Blindfolded?
let's go.
Okay, maybe we'll see. Okay, so here's the thing. I am going to trust you, because we don't want to, mess up the data. I'm going to trust you to keep your eyes closed. We're high schoolers, right? We can do that. I think Haley actually brings up a valid point that I would not have thought of. Could you use your nose to help figure out what Skittle you're tasting? You can smell it, right? Yeah. So, what I will ask is this. I will ask you to keep your eyes closed, use one hand to close your nose, and then your partner is going to hand you a Skittle. Sorry, Leah. Hand you a Skittle, and you're going to taste it, and you're going to tell your partner what Skittle you think it is. Does that make sense?
Put it all in there.
Intriguing?
So I am tasting this good one.
You are tasting the Skittle. Yeah, we're actually eating Skittles. The second thing that I want to ask is this. We're not going to go into all of it yet. We're going to go into this later. But I do have to ask, before we start this experiment, we start this study, it's not really an experiment, it's an observational study more than anything. What's going to be our null hypothesis? What's going to be our alternative? We should always define these things before we start doing a test.
I'll say that the null is that,
You can taste the Skittle.
yeah.
Okay, but how are we going to put that in terms of an alternative hypothesis? Because what type of parameters are we studying right now?
This is,
We're studying proportions, right?
Yeah.
So what do I need to use? I need to use a p versus, nope, not a p hat, sorry, versus a p equals versus less than, greater than, whatever. So come on, well, what do we think the p should be?
0.2,
Why 0.2?
because there's 5 Skittles.
Okay, there's 5 Skittles, so why 0.2?
There's like a 1 in 5 chance of guessing it right.
Is there a 1 in 5 chance of guessing it right?
Yes.
Okay. Okay. So in a lot of ways, as a probability-based idea, that would be by chance alone. You're getting roughly 1/5 of them correct. And so if you can really taste the Skittles, what would the alternative hypothesis be?
Yeah, I'd say 0.8.
Maybe greater than 1.2.
We gotta be careful. We don't ever say that it is another value. We are just doing greater than, less than, or not equal to the null hypothesis.
So technically, if you tasted let's say you had 2 green, 1 yellow, 1 blue, and 1 red. If you tasted both the green and the blue correctly, would that fail to reject the hypothesis?
We gotta run the test.
I'm saying, would that wrong language, but would it prove true that you could taste the rainbow?
We gotta run the hypothesis test.
You drive me insane.
I'm telling you, you can't just look at a little bit of data. By the way, I need us to think about this detail. You named what, 5 or 6 Skittles? Do we think a sample size of 6 would be enough for a hypothesis test? Why not?
No, because n needs to equal a bigger number.
Why?
Because it just has to for central limit.
Replication.
Do we need the central limit theorem?
No.
Replication.
It's proportional.
What is it? There's
Replication.
more information somewhere.
Say it, Austin. We need large counts. We need large counts theorem here. So that's a good starting point to think of. Any guesses what sample size we might need for the large counts theorem?
30?
20 or 30.
Would they
Point
be
two.
30, but usually
That's
it's
such a
20.
limit.
It would be.
Central limit theorem.
I'm actually-
Remember, so look at this. What is the large counts theorem? Bless you.
Your expected successes and failures need to be equal to 10
Not equal to,
or greater than.
greater than or equal to 10. Remember, expected successes and expected failures need to be greater than or equal to 10. So what sample size do we need at the bare minimum?
50.
So
1 million.
50 times 0.2, would that be greater than or equal to 10?
It'd be
Yep.
exactly 10.
It'd be exactly 10. And then this would be times 0.8. So that would be the 40, right? 10 here, 40 here, that's my 50. Now we're gonna do more than that, but that's something we need to think about is, hey, I want to satisfy the conditions. Any other guesses, or any guesses what other conditions we need to satisfy?
Random?
Oh, do we need to have something random?
Yeah.
Yeah, if our data is not collected randomly, what is our data?
Usage.
Crap.
It's biased, so it's what?
Crap.
It's crap, right? Like it's a crappy set of data. So it's got to be the large counts condition for what? Normality, right? There we go. It's got to be random to have decent data and also 10% condition, right? We're not guaranteeing that we're doing less than 10%, but it'll be okay. That just means we'll proceed with caution. But we're missing something from this statement here. Oh, actually, pause. Sorry, I skipped one important step. Any guesses what the 4 steps might be for this, I don't know, hypothesis test?
State plan.
State, plan, do, and conclude. I told you this before. Is that ever going to change for inference procedures? No, right? So state, what do you think is going to go under the state portion here? So my null and my alternative. So my null was p equals 0.2. What was my alternative?
Is greater than.
Is there anything I'm missing with that?
Don't you need the
You have to determine your parameters.
Okay. Context. Sorry, Pan, I didn't hear what you're saying. What were you saying?
nothing. I said you need something, but I don't know what it is.
Okay. So P is what? Like when we say P, we need to know what P is. We need context. P is the true proportion
Of guests.
of Skittles we can taste correctly, right? Why would we not say guess here?
Because you're not guessing.
Because the whole point is that we're trying not to guess. We're not trying to make it random. We're trying to correctly taste them, right? Why do I have to say true proportion?
Because that denotes that you're talking about
Yes.
the
We
population.
have to be talking about a population. There is one last thing that goes under the state portion. It's what? Once we collect the data, right, we will put the statistic there. But there's one other thing, and if you're looking at the sheet, yeah, what is it that we're missing? Significance level, alpha equals 0.05, there we go. Do or state plan, what are we putting under the plan? And my conditions, and you say formulas, is that what it has there? Yeah, it just says name of procedure and check conditions, right? So really you should start with the name of the procedure. What is the name of this procedure going to be?
Taste the rainbow.
Is it a confidence interval or hypothesis test?
Oh.
What is it? This is a hypothesis test. What type of hypothesis test do you think we might call this?
A proportion.
Oh, one proportion
Z.
hypothesis test? So one proportion hypothesis test. I think you could use the Z in there. I'll look for that.
Is this also a Z interval? Or?
Well, would it be a Z interval?
It's not.
It's not an interval, but it would be based on a Z score, right? Our standardized test statistic would be Z in this case.
So what's the parameter in statistic?
Parameter, right? Our statistic is going to be p hat, but we don't have that yet. One proportion hypothesis test, and I would say Z equals So when I say z equals, what am I going to put into the, what is the formula for z equals?
Value minus
What's my value going to be?
p hat
My statistic
e.
minus the parameter,
Over n.
Huh?
Over n.
No, it'd be
Or standard
the
deviation.
standard deviation of p hat since
would it be standard deviation of p hat, or would it be the standard deviation of p, or would it be s of p hat? Standard deviation or standard error?
In this situation,
standard error.
yeah.
Hold on.
You don't know the p.
I can't remember if I talked about this last week or
Oh,
not.
yeah, because we use p hat.
It can't be the one that's just like sigma because we don't
But we
know.
don't have the proportion, so we couldn't.
Can you let Bryson in? Well, here's the thing, and I need y'all to pay attention to this. I think I talked about this last week, but with a confidence interval, did we have anything for p?
No,
No. But in a hypothesis test, do we have something for p?
yeah,
Yeah.
yeah.
So we are going to use this for a hypothesis test. Because what was my assumed null hypothesis? That p is equal to
0.2.
0.2. So guys, if we have a hypothesis test with that null hypothesis, we are going to use the standard deviation, not the standard error. So the standard deviation of p hat, not the standard error of p hat. Does that make sense why we're doing that? Blank stares? Yes? No? Maybe so? So, hey guys, let me say it this way. If you have a p, use the p. If you don't have p, can you do this? No, you have to use p hat. Okay? So if you have a p, use p. If you don't, you can't. Alright. Bryson, you're going to be in Aaliyah's group to help them collect data because she can't eat Skittles right now. Sweet. Let's get up. Let's move to our groups. Let's collect our data. Let's try to get that data collected within 4 to 5 minutes. Yes, sir. 4 to 5. Let's go quickly. Run like the wind, bullseye. We got to collect our data quickly. The Skittles cups are on the desk back there. Grab a cup of Skittles. Keep a record of how many correct that person guesses or tastes, and then we'll put our data together.
What kind of person can't taste Skittles?
There's way more than 50 Skittles, but let's do this. Let's do 10 to 15 per person, and then we'll pool our data together.
Smells like burnt rubber.
So 10 to 15 per person, then we'll pool our data together. Come on.
This is burnt
Come on.
rubber.
I'm missing my partner.
You want some?
By the way, we do know the flavors, right? Red is strawberry, yellow lemon, green lime, orange, and purple is grape.
I do now.
All right,
I think
now we know.
when I ate it.
Alright, I'm gonna go first.
So what do we do?
Y'all are the ones eating them.
Alright. So just like.
No, also just said.
You have to, yeah.
And what do you mean by split them, like
Eat it.
even?
Because you could smell it.
Just close your
Yeah.
That's what I do.
Can you smell like the different flavors of Laffy Taffy?
Pour them in my hand and shake them.
Yeah.
I'll see you.
Yeah, so if it's 10 to 15 per group, and we pull all of our data together, will we have at least 15?
I guess we can.
I don't know. It's actually way harder than I thought.
Yes, 10 to 15 per person. Will we have?
I got two other ones.
The whole class.
I think it's right.
Is that order?
It was not. It's actually way harder than I thought.
Wait a minute. So how are we doing this?
So I put down like a tally.
Okay, so there are no treatments. What else? Okay, so just observing. What else?
I mean, I can list off characteristics of like an experiment.
Okay, but what's the goal? That's one of the big things we were forgetting.
There we go.
Say again. Okay, so inference about population, right? No treatments, things like that. So which one of these were there no treatments in, and we're just trying to make an? So we had two different ones that we were thinking, right? So what do you think the treatments were in Railside?
I mean, they did it at different schools. They did it like a Hodgson school. They did it like a lower end high school.
Okay.
Did they? I can't remember if they
So-
did different types of teaching.
They did do different types of teaching, and those are explanatory variables. But what makes a treatment a treatment? The researchers assigned it, right? Did the researchers ever assign the school their population or assign the school what type of teaching style? They did not. And that's what we want to notice and we need to pay attention to. No treatments were ever given. No, the researchers never said you have to do blank, okay? So this is not an experiment. This was an observational study. And I think the big reason why people get confused here is ultimately, do they want to be able to make a statement about cause and effect for one teaching style producing better results? Yeah, they would like to, but they can't. But what kind of inference about the population can they still make even if it's not causation? They could do correlation. This was an observational study for correlation between teaching style and learning, right? And they measured it, right, through those tests, but they want to know, hey, do these different teaching styles correlate to better learning? They couldn't say cause, but they did look at correlation. Does that make sense? So that's my observational study. So Milgram's study on obedience must be the experiment. And people don't see that always, right? And it's not a great experiment. Why not?
Because they only use men.
They only use what?
Men.
Say it again.
Men.
See, that's actually not a problem with this experiment. Why is that not an issue for the, and see, this is why we're doing this as a review. So remember, if you only do men, you only look at men, that means you can't make an inference about women, but what's the goal of an experiment?
Cause of, I mean, yeah.
It's okay.
I can read
You're just throwing those, yeah. Look, that experiment's all about cause and effect. And literally, what's the explanatory variable, what's the response variable, what's the cause, and what's the effect?
It's not working.
What was causing what?
Just like
So, authority figures were affecting people's what? Obedience. So it was an experiment, not a great one. There's a lot to improve upon, right? But what did they want to know? They wanted to know authority figures affect obedience. So, for example, what was the authority figure in the Milgram study on obedience?
It was the teacher role, right?
So remember, the teacher role was the subject. That's the person who, the question was, are they going to be obedient? But wasn't there a researcher in a lab coat and a clipboard who was encouraging the teacher to continue giving more questions? It looks like that person was an authority figure, was someone giving orders, and so the question was, would the teacher continue to shock the learner throughout that? Right? General goal, authority figures affecting obedience. Specific goal, right? That researcher who was giving the orders, did it affect the person, the teacher, giving more shots at higher and higher levels, even though it was marked as dangerous, right? Does that make sense now? Now there's a lot of issues that we're going to talk about, right? So remember, what affects in an observational study our ability to make an inference about the population or make an inference about correlation? What's the problem? Bias. Bias is the problem. That's why we can't make an inference about cause and effect. So the question I have for you that I want you to think about, first off, what elements of bias did they take care of? Those are the elements of study design that we want to think about. And what elements of bias did they not take care of that we need to add on to this study design? So what elements of bias did they take care of? I say, did they randomly select? See, and that's one of the biggest issues that people have, that y'all have when you read the study, and it should be an issue, is they didn't randomly select. There's a reason why, but what else?
They only 2 people, or when they did questions, they had 2 students.
Ah, so they had pairs of students. Why do you think they did that? What element of bias did that reduce?
No response.
That may have reduced the response bias, right? They kind of hold each other a little bit accountable, maybe, or encourage each other to speak the truth. Now, they might also feel some pressure to say certain things, so you can talk about both ways. But pairs of students maybe reduce response bias, and so we need to talk about that bias and how. So remember, in the AP exam, we want to name the thing, but then we also need to explain how it's doing that. So how is it reducing response bias? Do you have to have a perfect answer? No, but do you need to have a theory that's valid? Yes. Right? So it's reducing response bias. Was there anything else that they used to reduce bias? Hey guys, grab a seat. Just everybody grab a seat. In a desk, away from each other. I know, I'm sorry guys, you're getting punished for them being goofballs, but grab a seat. So, what other elements of bias? I know it's been a while since we've read this, but
They randomly selected the student.
so they did randomly select those students to interview, I think, right? Okay, so that did help with the data collection in that regard. Do you remember what they did whenever they recorded videos? So they recorded a lot of videos of teachers teaching.
They segmented their time into different like questioning and
And it's called coding, right? So they coded the types of questions. Where you been? Where you been?
I had those on my sheet.
Did you tell me that? Did you tell me that?
No, I didn't see you in here when I first came.
Okay, I'll have to change your attendance in a second. All right. Do you remember how many people? So it's called coding, right? They look at the types of questions, things like that. Do you remember how many people they had code every video?
2 people for each.
They had 2 people code every video. So what could that reduce? It was a measurement bias that we studied or talked about? Because could one person see it one way and another person could have seen it a completely different way, but we put it together, right? And we compare it, it increases the validity. So 2 people code each video. Okay. Was there anything else that we remember they did to reduce bias? And remember that when we say bias and you want to define this and talk about this, right, that bias being anything that would cause our sample to consistently misrepresent the population, right? Was there anything else that they did in their data collection? Let me ask this. Is the junior class different than the senior class?
Yeah.
So if I collected data just from the junior class, could that give me skewed results? What about if it was just from the senior class? So what did they do to reduce that bias? They didn't just take it, they did take it from multiple classes, but didn't they also do it over 4 or 5 years?
Yeah.
And so they got to see data develop over time, right? And see how different teachers affected and how different styles affected over time. And so y'all talked about this, a lot of y'all wrote about this in the first Frere model. That's called a longitudinal study. It's not something we really study, but they collected data over many years. I would say that it's probably going to reduce that response bias or that measurement bias again, right? Because it's not responses as much as how you measure things. Okay. So with inference test, yes, and if you actually read their data collection and their analysis, they actually do a lot of hypothesis testing with types of tests we will study and types of tests we will not study. But yeah, they did that. But that's again not bias, right? You have bad data collection, you have bad data collection. So it doesn't matter how large the sample is. What are the types of bias? So we talked about measurement, we talked about response bias, selection bias. Would we did they reduce selection bias here? What do they do to reduce selection bias?
Well, I mean, they reduced it by, like, when they selected kids for interviews and questions and stuff.
How so?
They randomly selected.
Okay, so they randomly selected, so they reduced selection bias within the school, right? So that could be something you talked about. But is there any kind of selection bias that they did not reduce?
The school section.
Ah, so maybe a change, right? Selection of school? So yeah, one student versus another could be an element of selection bias, but one school versus another school could be an element of selection bias. But and here's a realistic thing: if you're doing a 5-year study, can you just randomly pick schools? No, you're gonna have to find someone who agrees to this, right? So that's probably why. But could you still make that suggestion to say, hey, this would reduce bias? Okay. Now, you do need to think about the type of random sampling, because if you just randomly sample schools in California, because they're from California, it was actually a professor at Stanford who did that study. If you randomly select schools, could you get all schools that just do the traditional method? Yeah, so what do we need to do to make sure we get some from each? We didn't do cluster, right? I need to have homogeneous groups, like those who do the reform-oriented instruction, those who do the traditional, and then, yeah, that's what I figured. And then we randomly select. And this is why I'm doing this, to force us to go back and look at that language, right? If we didn't look at this until the AP exam, we'd be in a world of hurt. Building it in now allows us to review these things. So those are things to consider. There's more that you can think about, but notice we need to identify the type of bias. We need to identify the way to reduce it or what they did to reduce it. Okay. Now, what's the issue in an experiment?
Confounding.
Very much so. Guys, what's hitting the floor? Huh? Like, I hear things hitting the floor and no one's picking anything up. Like, huh? So confounding, right? You need to talk about what confounding is and how they reduce it. So you remember how you said they only used men? Could men versus women react differently?
Yeah.
So by using only men, what have they reduced? They've reduced confounding. Does that make sense? Like that would be the direct control. That's a form of a way to reduce confounding. You see that now? So what are the elements of experimental design that can reduce confounding? Say again?
Random assignment.
Random assignment. Okay, what else?
Random selection.
So remember, random selection is going to be under the elements of bias, right? So random assignment, what else?
Control.
A control group, right? Something you compare against.
And placebo. Didn't they have a placebo? Or, like, the shock wasn't actually shocking?
But so did the subject know that, though?
No.
No. So placebo, that could be an option. How about blinding? Either the researcher or the experimenter not knowing who's receiving what treatments, right? I'm trying to think of, I feel like I'm missing one or two. I'll have to go and look, and I'll send you an email if there's something I'm forgetting. But did they have random assignment? Did they? There was random assignment with who got the teacher and who got the learner, but remember, they actually rigged it so that the subject was always the teacher, and they had the same learner every time. So did they have random assignment? Well, no, and they couldn't have. How many treatments did they actually have? They had the one authority figure prompting them anytime they wanted to quit. That was it. There were no other treatments. So that's a problem, right? So we have to have a control group. We have to have something to compare it against. So if we want to know, is the authority figure causing them to act differently, what are some other treatments that we could have had?
Just have the teacher in there about themselves.
Okay, so teacher with instructions, and see how that compares. Maybe that could be what? My control group? What other treatments could there be? Something I talked about with the other group that the other group came up with is authority figure is silent. So authority figure present but silent. And notice now that I have multiple treatments, now I can randomly assign. Does that make sense? Oh, blocking, that's what I was thinking about. So we could have included men and women and had men in one group, women in a different group if we thought they would be similar but different from each other, and randomly assign the men to each of the treatments, randomly assign the women to each of the treatments. Does that make sense? So there's that. We talked about a control group. Was there any blinding? It was actually really, really, really important. Did the teacher know what was actually happening? No, the subject had no clue, so there was single blinding. The researcher knew what was happening. But that subject, like if they had known that it was fake the whole time, that would have completely messed up the results. It would have been a confounding factor. So that was there. And so those are things to consider. I think there's something else, but I got distracted by people talking so much. But make sure you identify what could have been confounding. Oh, another direct control. It was done at, no, not Harvard. Was it done at Harvard? Or MIT? It was something like that, right? But it was done at an official site to make it seem legit. Right? That's direct control / blinding. It helped play into that. So identify the things that they took care of in terms of confounding, right? And then use the statistical language, the vocabulary, explain how it could have caused confounding and how they reduce the effects of confounding with that. Does that make sense? So take that, write all about it, improve that analysis so that we can be better prepared moving forward.
Mr. King, your wife teaches